Hey guys, welcome back to the channel. In this video, we're going to be looking at counting and the binomial expansion, which is chapter number 10. Let's begin with the product rule. You read the question in front of you and then we'll discuss the question and the answer. So it goes like this. Suppose there are 3 bridges in front of you. After crossing one of them, you encounter 4 more bridges. What is the total number of ways in which you can go from point A, which is the starting point, to point B, the end point? So think about this for a few minutes. I will draw the diagram. Let this be A. This will be M. And this will be B. So what is the total number of ways in which you can go from here to here? Okay, if you have the answer, then we'll discuss. I mean, it's given here, but I'll explain why that is. So from here to here, you can go in 3 ways, right? The first path, second, and the third path. So there are 3 ways to go from A to M. So this is 3. And from M to B, there are 4 possibilities. Because you can take this route, this, or this. So there are 4. And now if you want to go from A to B, you'll have to multiply them. So that's the reasoning. So if you go from A to M, there are 3. M to B, it's 4. So in total, it's going to be 3 into 4. We can like label all of them. So let's. The possibilities are 1A, 1B, 1C, 1D, 2A, 2B, 2C, 2D, 3A, 3B, 3C, and 3D. If you count this up, you're going to get 12 ways. So that's what is written here. If there are m different ways of performing an operation, and for each of these there are n different ways of performing the second independent operation, this is extremely important. The reason why is because imagine if you took route A, you will go to a different bridge. Then the events are not independent. And so therefore, it has to be an independent operation. Then there are mn different ways of performing 2 operations in succession. Also, it has to be in succession, one after the other. So that's the principle. If you do m different operations, and then after which you perform n independent operations, then the different number of ways of performing the operations is m into n. So that's the logic, or that's the statement. Okay, and the product rule can be extended to 3 or more successive independent operations. Okay, imagine from here you have 2 more paths. Then what would be the answer? Think about it. Okay, so it's going to be 12 into 2. This is going to be our answer, which is 24. If this is clear, then let's move on to the questions. Take a couple of minutes to answer these. Let's look at the first question. A table tennis competition has 7 teams. In how many different ways can the top 2 positions be filled in order for premiership points obtained? Let's put this as the first place and the second place. The first place can be filled by 7 teams. So any one of these 7 teams can win, right? So that's why we put 7 in the first place. Okay, imagine team, I don't know, C has won. Team C cannot win the first and second place, right? So therefore, we're gonna have 6 possibilities for the second place. So what we need to do right now is multiply them because of the product rule, and now we're gonna get 42. So that's the answer. Because the first position can be filled by 7 teams, but for the second one, it can only be filled by 6 teams because a team cannot win, cannot fill the first and the second position. And now let's look at the second one. How many 3-digit numbers can be formed using the following digits? Okay, let's draw this. This is the hundreds place, tens place, and the units place. So if we can use any of these 5 numbers as often as we desire, then the first place can be filled in 5 ways because, well, we have 5 numbers available. So this can be filled in 5 ways. Even the second one can be filled in 5. Even this. Now we have to multiply them because they're in succession and they're independent events. So it's going to be 125. That's the answer. And at most once each. That means they cannot be used 2 times or 3 times. So the first place can obviously be filled in 5 ways. Now let's look at the second one. Imagine 2, we had the digit 2 in the first place. Then we can't use this again. So we cancel this out and we use the remaining 4 digits to fill the second place. So this is going to be 4. And now just imagine that the number was 3. We cancel it out. And now there are 3 available digits. So 3. Now we multiply them because of the product rule. This is going to be 20 into 3, which is 60. This can be done in 60 ways. Let's look at the last question. A football competition is organized between 8 teams. In how many ways can the top 4 places be filled? This is very similar to the first question. We do 8 into 7 into 6 into 5. The logic remains the same. So this is going to be 1, 6, 8, 0. So that's the answer. I hope this topic is clear because this is going to be really important. And also your logical reasoning is important in this chapter because you're going to have to think logically about like the real life scenarios in order to answer these questions. So for example, the first one. Imagine you did not know that a team could not win the first and second place. We all know this. This is common knowledge. But if you didn't, then you would have done 7 into 7, which would have been 49. But that's not the case. So therefore, you should be thinking a lot in this chapter. Let's move on to the counting parts. This is very similar to the product rule. But in this one, we're going to look at different possibilities. So I really like this example, so I'm going to explain this. So we have to consider the road system illustrated, which shows the roads from P to Q. This is P, this is Q. From A to Q, there are 2 paths. A to Q, there are 2 paths, 1 and 2. And from B to Q, this is the counting principle, the product rule. So this is going to be 3 into 2, which is 6. So 6 ways. And then from C to Q, there are 3 paths, 1, 2, 3. This is going to be 3, 6, and 2. And so therefore, from going from P to Q, there are 11 paths. We have to add them. In this case, we're adding them because of the word or. We can choose this path or this or this. And therefore, we add the numbers. If it's and, then we have to multiply. If it's or, we have to add. Now let's look at a few examples. These are very similar to this one. So let's label this as A. To go from A to Q, we can either cross this path, and so on. So this can be done in 4 into 2 equals to 8 ways, or we can go from P to Q this way. This is going to be 3, 2, and 2, and we multiply them. It's going to be 6 into 2, which is 12. So therefore, total would be 8 plus 12, 20. Let's do the same for this one. This is 2, 4 into 2, 8, 3 into 3, 9. Therefore, 19 ways. I hope this was simple. Now let's look at factorial notation. A factorial is anything in the form of n factorial. So this symbol, the exclamation mark, signifies factorial, and n is an integer. So for n greater than or equal to 1, n factorial is the product of the first n positive integers. So we have n factorial. So it's going to be n into n minus 1 into n minus 2 into n minus 3 and so on into 3 into 2 into 1. Let's take a few examples. So 5 factorial will be 5 into 4 into 3 into 2 into 1, which is 120. Let's take 2 factorial. It's going to be 2 multiplied by 1, which is 2, and so on. So that's how this works. So an alternative recursive definition. Of factorial numbers is which can be extended to n factorial equals to n into n minus 1 into n minus 2 factorial. This is important, and so on. Using the factorial rule with n equals to 1, we have 1 factorial equals to 1 into 0 factorial. And therefore, for completeness, we define 0 factorial as 1. There's really no logic to it. We just define 0 factorial as 1 because it's convenient. First of all, we're going to get things like NCR, which we're going to learn soon. In this one, if R was 0, no, this. In this one, when we come across it, if we have something that is to the factorial of 0, we can't divide a number by 0. We don't know what it is. It's undefined. So therefore, for convenience sake, we define 0 factorial as 1. And now let's look at this point. It says n factorial equals to n into n minus 1. So therefore, what we can write 6 factorial as is 6 into 5 factorial. It's essentially the same thing. And 5 factorial can be written as 5 into 4 into 3 factorial. Or we can write 200 factorial would be 200 into 199 into 198 into 197 factorial. This is how it works. And now let's solve some questions. In these questions, you'll have to simplify the expression as much as possible. Okay, now let's look at the first question. We have 6 factorial divided by 5 factorial. We can write 6 factorial as 6 into 5 factorial divided by 5 factorial. We can cancel this out and we're left with 6. As you can see, this is very simple. And now let's look at a similar example. 6 factorial would be 6 into 5 into 4 factorial divided by 4 factorial. We can cancel this out and we're left with 30. And now this might seem complicated, but let's break it down. We can write n factorial as n into n minus 1 factorial plus n minus 1 factorial divided by n minus 1 factorial. We'll take n minus 1 factorial as common. So we're left with n minus 1 factorial into n plus 1. Then we divide this by n minus 1 factorial. This cancels out and we're left with n plus 1. Now let's simplify this. The top can be written as n plus 1 into n minus 1 factorial divided by n minus 1 factorial. Cancels out and we have n squared plus n. We can write 12 factorial as 12 into 11 factorial minus 2 into 11 factorial. Let's take 11 factorial as common. 11 factorial, 12 minus 2. This is going to be 11 factorial into 10. We can leave this in this form. And now let's do the same with this. We can write 9 factorial into 10 plus 1 divided by 11. This cancels out. We're left with 9 factorial. And we have the last set of questions. N plus 2 factorial can be written as n plus 2 into n plus 1 multiplied by n factorial divided by n factorial. Therefore, we have n squared plus 3n plus 2. Simple, right? Now let's solve this one. The lowest is this one. So we can take 6 factorial as common. So it's going to be 7 minus 1 plus 8 into 7. That's 6 factorial into this would be 6 plus 42. 6 factorial into 48. And now, yeah, no, that's all. This is all we can do with this. And so we're done with all of these questions. The next topic is the binomial coefficient. This is used for permutation combinations. It's mainly used for combinations, not really for permutations. For permutations, we use NPR instead of NCR. But now let's just concentrate on what it is. So it's defined by brackets NR in the vector form. Or you can write this as NCR or CNR. So these are the three ways you can represent the binomial coefficient. And this is defined as n factorial divided by r factorial into n minus r factorial. This is something you'll have to remember, but there is this function on your calculator that you can use too. Either way, it's good to remember this because there are certain questions that do ask you to expand this, without like using the calculator. They will tell you to prove something in something, and therefore you'll have to know the expansion. So this is important. Just remember that it's n factorial divided by r factorial into n minus r factorial. Well, just think of this as n, and the bottom one, instead of multiplication, think that it's addition. So r and r get cancelled, left with n and n. That's how I remembered, but you can remember it however you want. Now let's work out an example. Let's do this one. Expand this. This is basically 5c2. It's going to be n factorial divided by r factorial into n minus r factorial. Here n is 5, r is 2. Therefore, this would be 5 factorial divided by 2 factorial into 5 minus 2 factorial. We can write 5 factorial divided by 2 factorial into 3 factorial. 5 would be 5 into 4 into 3 factorial divided by 2 factorial multiplied by 3 factorial. These get cancelled out. We can simplify this to 5 into 2, which is 10. This is the answer. And now let's do some more examples. Let's work out this one. Go ahead, give it a try. This is 4, by the way. Give it a try. This is going to be 4 factorial divided by 2 factorial into 2 factorial. It's going to be 4 into 3 divided by 2, which is 2 into 3, which is 6. That's the answer. And now let's look at one of the show questions. This is show that this is this. Okay, we know that NR is NCR. So it's going to be n factorial divided by r factorial into n minus r factorial. Let's do the same for this one. And multiplied by, this is going to be n minus of this, which is going to be n minus of minus r, which is plus. These get cancelled out. We're left with the same thing. This is one of the most important properties of the binomial coefficient. So when we're doing the combinations, you'll understand why. So I'll just try to explain this right now. You don't have to really know this right now. Once I explain permutation combinations, this will make a lot more sense. Imagine you have 5 boxes. So you want to choose 3 of these boxes. In how many ways can you do that? You can do this, 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 and so on, right? This is the same thing as leaving. So choosing 3 boxes is the same as leaving 2 boxes. So let's say we give the first 3 boxes, not the first, any 3 of the boxes to person A and 2 of the boxes to person B. So if we give 3 of the boxes to A, it's the same thing as saying we give 2 boxes to B. And so therefore we get 5C3, which means that you're choosing 3 artifacts or things out of the available 5 items, which is also the same as 5C2. That is why this is very important. So we know that 5C3 is 5C2. So choosing 3 from 5 things is the same as choosing 2 from 5. It's like choosing this, leaving this. That's the principle. I hope that's clear. Now let's solve the last question. It says find k if 9k is 4 into 7k minus 1. It's going to be 9 factorial divided by k factorial into 9 minus k factorial, which is 4 into 7 factorial divided by k minus 1 factorial multiplied by 7 minus k plus 1 factorial. We can expand this. 8 into 7 factorial divided by k into k minus 1 factorial. And this will be 9 minus k factorial. It's going to be k minus 1 factorial multiplied by 8 minus k factorial. We can cancel 7 factorial and 7 and this and this. And now we can write this as what's 9 into 8? Okay, let's just leave that. I don't know. K into, this is gonna be into 8 minus k factorial. It's going to be 4 into 1 divided by 8 minus k factorial. This gets cancelled and this gets cancelled, and we're left with 18 by k multiplied by 9 minus k is 1. We can write 18 is 9k minus k squared. So k squared minus 9k plus 18 is 0. Now let's calculate this. I do not have my calculator with me right now, but I'll just try to work it out. This is 9. Oh, wait, never mind. K is just 3 or 6. You factorize it. So this is what we get. Now time to move on to permutation and combinations. Most students find this topic the hardest, including me. I struggled with permutation and combinations last year. It's all about logic, and like the more you practice, the more amount of questions you do, the easier it becomes. If you just do 1 or 2 questions and then expect to get all the questions right, that's not going to happen. So you're going to have to practice a lot. More than me explaining the concept, I think it would be beneficial if I work through problems, because that's how you understand permutation combinations. Even if I explain the theory, you will only understand how to manipulate the things, how to use permutations while we do the questions. So it's fine if you don't really understand anything when we just do the theory part. A permutation of a group of symbols, my bad, is any arrangement of those symbols in definite order. One thing you're supposed to know is that permutation deals with arrangement. Sorry, 1 second. With arrangement, order, etc. Anytime you see the word arrange, order, or anything along the lines of these, you're supposed to know that you're supposed to use permutations. The difference between permutation and combinations is that permutation deals with arrangement and so on, while combination deals with selecting certain things. In permutations, the order of things that you put in a line or you choose, it matters, but in combinations it does not. I'll give you an example. So imagine we have A, B, C. Let's just take a very simple example. So let's say we take 2 and we arrange them. So let's say A, B, B, C, A, C. This is the combinations, 3. You can't do anything else. Even if you choose B and A, you're gonna end up with the same thing. If you choose C and B, it's the same thing. But for permutations, it can be B, A also, because like I said, order matters. The arrangement of these matters. And therefore, permutation deals with arrangement, ordering of things, and combination deals with selecting items. Okay, for example, BAC is a permutation on the symbols A, B, C. In all of these, 3 of them are used, and we say the symbol are taken 3 at a time. The set of all the different permutations on the symbol A, B, C taken 3 at a time, note it's 3, but I used to, is ABC, ACB, BAC, BCA, CAB, and CBA. So suppose we want to find the number of different permutations in the symbols A, B, C, D, E, F, G, taken 3 at a time. So there are 3 positions to fill. The first one, second one, and third one. So the first position can be filled in seven different ways, and the second one in 6, and then this 5. And now we use the principle, the product principle, to find this. So it's going to be 7 into 6 into 5. So that's how we get this. And remember we saw NCR, right? There's something called as NPR. P deals with permutation. So the number of permutations on n distinct symbol taken r at a time is n factorial divided by n minus r factorial. So let me give you an example. We have 5 chocolates, 5 different types of chocolates. Okay, it's not writing. Okay, and now imagine we take 2 at a time. What would be the number of ways we could do this in? So let's apply this formula. It's going to be 5 factorial divided by 3 factorial, which is 5 into 4, which is 20. So this is how you do it. I hope this is clear. And now let's just move on to the questions. The first question, in how many ways can 5 different books be arranged on the shelf? It's 5 books taken 5 at a time. So it's going to be 5 factorial divided by 5 taken 5 at a time. So 5 minus 5 factorial, which is 5 factorial divided by 0 factorial. Do you remember why we define 0 factorial as 1? It's for this. Because if 0 factorial was 0, well, this would be undefined. But that's not the case, right? It's going to be 5 factorial divided by 1. So that's why 0 factorial is 1. It's just for convenience sake. So this is going to be 120. Okay, the next question. 3 different paintings can be chosen from a collection of 8 hung in a row. So 3 from 8. So 8, it's going to be 8 P 3. So 8 factorial divided by 5 factorial. It's going to be 8 into 7 into 6. This is going to be 336. Now the next one. A signal consisting of 4 colored flags in a row be made if there are 10 different flags to choose from. It's going to be 10p4. It's going to be 10 factorial divided by 6 factorial. It's 10 into 9 into 8 into 7, which is 5,400. Let's check the answer. 120, yeah, and yeah. And then now let's do the second question. A captain and vice captain are to be selected from a team of 11 cricketers. In how many ways can this be done? All right. So there are 11 people in the cricket team. So 11 available. And a captain can be chosen from 11. So 11 into, there are 10 options. So it's going to be 110. Let's see the answer. Yes, that is indeed the answer. 3-digit numbers are constructed from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, using each digit at most once. How many such numbers can be constructed? We have 3 digits. So the first can be occupied by 9 digits, because if we put 0 here, then it's going to become a 2-digit number. And therefore, this can be filled in 9 ways. And this can also be filled in 9 ways because it can be occupied by 0. And this is going to be 8. So 9 into 8 into 9. That is going to be 648. So that's the answer for A. And now B. They end in 5. Similar to this question. It's very similar, but it has to end in 5. So this can be occupied by 1 digit, which is 5. And the first one cannot be occupied by either 0 or 5. So it's 8. Then this is going to be 8 also, because we have 5 here and we have some other number here. So it's going to be 8 into 8. So it's 64. And C, it ends in 0. This can be occupied in one way, this 9 and this 8. This is 9 because 0 is already here and we don't have to worry about that. So it's going to be 9 into 8. That's 72. And are divisible by 5. As you might know, if a number is divisible by 5, it means that it either ends in a 0 or 5. And we've already found out the possibilities, the number of ways that it ends in 5 and it ends in 0. So we just have to add them. So it's 64 plus 72, which is 136. So that's the answer. Let's verify this. Yes, that's also what we got. And now consider the letters of the word Monday, M-O-N-D-A-Y. How many permutations of 4 different letters can be made if there are no restrictions? If there are no restrictions. We have the word Monday, and we are selecting 4 from the available 6 letters. It's gonna be 6p4, which is 6 factorial, divided by 2 factorial. This will be 6 into 5 into 4 into 3, which is 360. And we have to find the number of ways in which the vowels, it uses at least one vowel. So it's going to be the total number of ways minus the number of ways in which they're not there at all. So it's going to be 4 factorial, which is 360 minus 24, which is 336. The last question, the 2 vowels are not together. So the total number of ways is 360. And we have to find the number of ways in which they are together. Therefore, it's going to be 4p2, because we're selecting 2 from the available 4, which are not vowels, into 3 factorial. It's going to be 360 minus, it's going to be 12 into 6. It's 360 minus 72, which is 288. So the first answer is 360, the second is 336, and the final answer is 288. Let's check the answer. That is also what we got. And with that, we're done with permutation. Try to solve a lot of questions from the book, from the past papers. And yeah, now we'll do permutation. We'll do combinations. We have already talked about combinations, but I will just do it again. So combination is a selection of objects without regard to order. As we know, permutation is, we consider the arrangement. we try to arrange them. But here, we just have to select the objects. So number of combinations is number of permutations divided by r factorial. And that's how we get the formula. And we've learned about the binomial coefficient. So NCR is n factorial divided by r factorial into n minus r factorial. Okay, let's take a few examples. Let's say there are 13 dancers in a class and only 5 make it through to the finals. Not the finals, through let's say a competition. So what is the number of ways in which that can be done? It's going to be 13C 5, which is also equal to 13C 13 minus 5. We know this because 13 minus 5 people won't get selected, and therefore these two are equal. Also, we can take the example of a sport. Let's say there are about 50 people try out for the basketball team, and only 8 of them will make it. So the number of ways in which that can be done is 50C8. Here we don't have to worry about the order, because if you choose, let's say, a guy called B, a girl called A, and a girl called C, the order in which you arrange them or choose them won't matter. It's about these 3 people, and therefore order does not matter in combinations. That's the main difference between combination and a permutation. Time to do some questions. Let's look at the first one. How many different teams of 11 can be chosen from a squad of 17? This is very simple. So we know that there are a total of 17 people, out of which 11 have to be selected. And this is selection because of the word chosen. If it said, how many different ways can 17 people be arranged, taken 11 at a time, then we would do permutation. But here, since they have been chosen, it means that we need to use combination. And we know that we have to use the NCR formula. Here n is 17, r is 11. Therefore, 17 C11 is 17 factorial divided by 11 factorial multiplied by 17 minus 11, which is 6 factorial. 17 into 16 into 15 into 14 into 13 into 12 divided by 6 factorial. Let's find this. This is 12,376. This is the number of ways in which a team of 11 can be made from a squad of 17 people. So this is how you approach questions. And now let's look at this one. Candidates for an examination are required to answer 5 out of 9 questions. In how many ways can the question be chosen if there are no restrictions? This is very straightforward. It's going to be 9C5 because I've already explained the reasoning behind this for the previous question. So 9C5 is 126. And if one question was compulsory, how many selections would be possible? So we know that if one question is compulsory, then we'd have to choose 4. So R would be 4 because we have to select 4 at a time. And we don't have 9 possibilities. We can't do that. So we don't have 9 available questions. We have 8 now, right? Because since one of them is compulsory, we don't have a choice to exclude it. And therefore, we have to remove that. And we're left with n equals to 8. And therefore, 8C4 would be our answer. This would be 70. I hope you've understood the reasoning behind this, because it's very important to know these questions, because they come in the past papers very frequently. Now let's solve the next one. This is easy. How many different committees of 3 people? 3 can be selected from 13 candidates. 13C3, because we're selecting 3 from the available 13 people. So 13C3, it's 286. That's the number of ways. All right. In how many ways can 4 people be selected from 10 if A, one particular person must be selected? If one person is selected, okay, let's just draw this. Let's say person C is getting selected. Now we have 3 slots or 3 places, and therefore we have R equals to 3. And since we've already chosen this person, we can exclude him from that group. So it's going to be 10 minus 1, which is 9. So n is 9. NCR would be 9C3, which is 84. This is the answer to part A. Now let's look at B. 2 particular people are excluded from every selection. So these people are not included in the group. So 4 empty spaces. And if they have to be excluded, that means we have to take them out of the group of people that might be selected. So it's going to be minus 2, 8. We have to choose, we have to do 8C4, which is 70. This is the answer. So we're done with these 4 questions. Let's solve some more. Since we're done with these 4, let's move on to the next 2. Determine whether the following are examples of combinations or permutation. Making a 3-digit number using the digits 1, 2, 3, 4, 5 at most once each. This is permutation, because in this the order matters, because 1, 2, 3 is not the same as 2, 1, 3, and therefore this would be permutation. The first one is permutation. Selecting a committee of 3 from a list of 5. This is combination, because the order does not matter. And now selecting the chairperson and the treasurer from a committee of 8 people. In this one, the order matters, because let's say if a guy called A and a guy called B, the first one is the chairperson and the second one is the treasurer, but it can also be the other way around, right? So therefore here permutation is more apt. And then selecting 2 pieces of fruit to take to school from a bowl of 10 pieces, this will be combination, because it does not matter whether you take an orange first and then a banana, or like a banana and then an orange. So it's combination. I hope these examples made it much more clear and you do understand the difference between combination and permutation. And now let's look at this. These are the type of questions that you will often get. So let's do this. A committee of 8 is chosen from 9 boys and 6 girls. Find the number of ways it can be done if there are no restrictions. If there are no restrictions, we have to choose 8 from a total of 15. So it's going to be 15C8. This is 6,435. And there must be 5 boys and 3 girls. If we choose 3 girls, from 6 we have 6C3 into 5 from 9. So 9C5. This is how we do it. So it's going to be 6C3 into 9C5. This is going to be 2,520. This is the answer. And now if all the girls are selected, that means, but we don't have enough girls, right? Wait, never mind. All girls are selected. It means 6 girls, 2 boys. So 6 girls, 2 boys. And this can be done in one way, because if you choose all of the girls, there's only one combination. And if we can choose 2 boys from 9 in 9C2 ways, which is 36. That's the answer. That's how you derive it. And now let's look at D. This is somewhat complicated, but it's not that complicated also. If there are more boys than girls, we have to write down every single possibility. So wait, I'll show you. Let's take scenario 1. Eight boys, 0 girls. There are more boys than girls, so it's going to be 8, 9, C8, which is 9. Yes, 9 ways. 7 boys, 1 girl. That's going to be 9C7 into 6C1, which is 216. And now we'll write 6 boys, 2 girls. It's going to be 9C6 into 6C2. It's 1,260. Now 5 boys, 3 girls. We already found this out in B, which is 2,520. Therefore, total is 9 plus 216 plus 1260 plus 2520. Let's add this up. We get 4,005. This is the final answer. And now we're done with the questions I picked out for combinations. The next topic is binomial expansion. We know that the sum of a and b is a binomial, and it consists of 2 terms. And any expression of the form a plus b whole to the power of n is called a power of a binomial. We know the expansion of a plus b whole squared, right? It's going to be a squared plus 2ab plus b squared. And similarly, a plus b whole cubed, a plus b to the power of 4, and so on. These are all binomial expansions. We can find the expansion of a plus b. Let me take this example. We can find x plus 2 whole squared by doing x plus 2 into x plus 2, and we can also do the cubed by doing the same thing. But imagine it's to the power of 30. Won't it be really tedious? And therefore, people have derived a formula to expand this without having to multiply every single term. And also, you'll get it in like ascending or descending order, which is also very convenient. So you won't have to always add the like terms. When you do this, you get x squared plus 2x plus 2x plus 4. You got like terms, right? And you have to add them. But in this method that we're going to learn eventually, you won't have to do that. It's in ascending or descending order, depending on what the values of a and b are. So it's very convenient. And if you have like a huge power, you won't have to multiply this 30 times. And that's why it's so convenient. Now let's look at the formula. So if we have a plus b to the power of n, it would be a to the power of n plus nc1 into a to the power of n minus 1 into b. And it's going to be, the next one's going to be n c2, a to the power of n minus 2, and b squared. I have this like trick to remember that really helped me when I was doing the IGCSE exam. So you have this term, right? So the power of the first, this one, would be this minus this. And of the second term, it would be this number. So if you want to do this, it's going to be n minus r into b to the power of r. And so on until we get b to the power of n. So this is where NCR is the binomial coefficient of a to the power of n minus r into b to the power of r, where r is a positive integer and it includes 0. The general term, or the r plus 1 term in the binomial expression, is NCR into a to the power of n minus r into b to the power of r. This is very convenient, so try to remember. You won't have to expand everything to know a certain term. Also, this would be given in the formula sheet, and therefore you don't have to memorize this, but I'd recommend that you memorize it because it might take a long time to plug in the values or look at each of these terms and then try to substitute the values. So it's going to be really hard. So if you remember it, it's going to be easy. And that's all I have to say for this equation. And using sigma notation, we write a plus b to the power of n is the summation starting from r equals to 0 to n, which is, it means that it just goes from like 0, 1, 2, 3. It goes by increments of 1 until it reaches n. And this would be NCR into a to the power of n minus r into b to the power of r. This is the formula. This is gonna come in every single paper that you write. I've like solved a lot of papers and it came in almost every single one of them. So this is very important. And if you're gonna continue with A levels, then this will be in P1 and P2, but no, P3. But in P3, you're gonna have the value of n would be fractions, negative, Instead of having to do the NCR method, there's one more easy and fun method, which is called as the Pascal's triangle. It's in the name, literally, Pascal's triangle. It starts with 0, and then we have 1, 1. And you're gonna add these two, and here it's 0, so it's gonna be 1 and 1. You keep doing that. So this is gonna be 3, 3, 1, 1. You do the same thing. And this is used to find the coefficient. This would, okay, let's take a plus b to the power of 4. We have 4c0, which is 1, 4c1, which is 4, 4c2, which is 6, 4c3, which is 4, 4c, 4, 1. You could either do this or this. And it keeps going on. It does not have an end. So this would be 10, 10, 5, 5, 1, 1. That's how you do it. Time to solve some questions. We have to find the coefficient of x cubed in this expansion. This is going to be 1 to the power of 10 plus 10c1 into 1 to the power of 9 into negative 3x plus 10c2 into 1 to the power of 8 multiplied by negative 3x whole squared and plus 10c3 into 1 to the power of 7 multiplied by negative 3x whole cube, and so on till negative 3x to the power of 10. This would be the x cubed term. Let's write this out. We can work out 10c3, it's 120 into negative 27 into x cubed. Therefore, coefficient is negative 3240. That's the answer. Now let's solve the next one. We have the same one. But now, instead of doing 1 minus 3x, let's take this as 3x plus 1. I'll tell you why this is more efficient. First, let's expand this. We have negative 3x to the power of 10 plus 10c1 into negative 3x to the power of 9 into 1 plus 10c2 multiplied by negative 3x to the power of 8 multiplied by 1 plus 10c3 into negative 3x to the power of 7 plus 1 and so on till 1 to the power of 10, which is 1, but yeah. The reason I did this is because if I want to find the coefficient of x to the power of 7, if I just wrote this like this, I would have to go through 8 terms in order to find the x to the power of 7 term. But by doing this method, I found it in 4 in 4 tries. And therefore, I use this. I just like flip them. 10c3 is 120 to negative 3 to the power of 7 into x to the power of 7. The coefficient is negative 262,440. It's a lot. So we got the answers. Find the term independent of x in the expansion of this. The meaning of independent of x, it just means that there's no x term, it's going to be x to the power of 0. So that's what it means. It's just going to be a constant. Let's expand this. You just go to keep writing this until you find a term that does not have the x term. And now we found it. It's 15c. Oh wait, I'm doing sorry. That's 4 and 5. 15c5 into 2 to the power of 5. These two get cancelled, so that doesn't matter. We get 96,096. That's the answer. Now let's do the same thing for this. It's a lot of work, so you have to ensure that you don't go wrong anywhere. I'm pretty sure we found this here. It's this term. Because x to the power of 6 divided by x to the power of 6 is 1. So n9c3 multiplied by 3 to the power of negative 3 to the power of 3. This is going to be 84 into negative 27. It's negative 2,268. That's the final answer. And with this, we're done with the whole chapter. I hope this video was helpful, and if you found it helpful, do subscribe and share it with your friends and family. Thank you.